Now we're going to talk about how to program your Hapkit, and this is where things get really fun. The Hapkit, it's useful for us to tell you a little bit about where it comes from. It comes from a base idea of the Arduino, which is a product, which is a single board microcontroller that makes using electronics in multidisciplinary projects relatively easy. That is, you can use an Arduino to easily connect electronic circuits to physical things in the world, like the LED we just showed, and of course later things like motors and other sensors that we'll have on our Hapkit. The Hapkit board is not actually an Arduino. It's very much based on the Arduino design. The Arduino design is an open source design, and so anybody can go and design their own boards that are based on the Arduino idea. But we made our own Hapkit board so that we could make it in the right size to fit with your Hapkit and have all the features that we needed. So there's some added features like the fact that it has an amplifier for your motor, and the MR sensor circuit is attached to the Hapkit board. Those are all things that you don't get in a regular Arduino. And so we tried to make it cheaper and more compact by designing our own board instead of using a standard Arduino. Now the nice thing is that the Hapkit board can be programmed using the same Arduino integrated development environment as an Arduino board. Now this IDE, or Integrated Development Environment, is really just a software program that lets you add in your own code and download it to your board. And so the Hapkit board will behave very much like an Arduino board, but just note that if you've previously written code for the Arduino, it won't necessarily work on the Hapkit board because some of the pins have been repurposed for other things. So just be a little careful when you are trying to use old code with your Hapkit board. So the next thing that you're going to do is to follow the instructions in the handout that we've provided to download, install, and test your Arduino software. And in order to do the testing, this will be the very last step in this download, install, and test document, there's going to be a Hapkit program that you're going to bring up and use. So you're going to be using this Blink program, and there's instructions on how to get to that in the handout. And when you open up that program, you should get a window that looks like this. So you're going to get this programming area where you can start typing things. I've just written a slightly simpler version of that same program here. It's very similar. It does the exact same thing, and we are going to actually step through this program and look at its different components in a minute. One thing to point out is that if you've never programmed Arduino, but you've programmed in almost any other language, you'll find that the language is very similar to other programming languages you might have encountered, most importantly C and Java. But whether you've used MATLAB or Fortran or any other programming language, a lot of the ideas are the same. You may just have to adjust the syntax a little bit. And also, if you've never programmed before, don't be intimidated. We'll be walking through what each of these commands do, and once you read some of the documentation for the Arduino programming environment, you'll have down all of the syntax that you need to know. So, once you have a program like this in the IDE, in the Arduino development environment, you want to run it. So let's assume you've got your program all set and you actually want to put it onto your Hapkit board and have it run. So one key thing to understand is that the programs that you write are not running on your computer. Your computer is simply a development environment that lets you program the Hapkit or develop the programs for your Hapkit. And you actually have to get those programs sent down to the Hapkit board in order for them to run and do anything with your Hapkit or the Arduino. So there's two ways you can run a Hapkit program. One is you can go into the menus above the program and click on File and then Upload, and so you can go this path. Another thing that you can do, and it depends on what version of the Arduino development environment you have and whether you're using a Mac or a Windows-based PC or even Linux, your window might look a little different. But in this particular picture, this circle with the right arrow is an upload button that if you click, it will upload it to your board. So you can go ahead and try that now if you haven't done it already, knowing that clicking upload sends the code from the computer to the Hapkit board. And if you get an error at this point, you should recheck your instructions about having the right serial line chosen and that you've installed any necessary drivers, especially if you're using a Macintosh. So hopefully you've now been able to upload your program to your Hapkit and something should be happening. Your code should be running on the Hapkit board. So if you look at the little circuit that we designed recently, you should see your LED doing something. So to understand what it should be doing and why it's doing what it's doing, let's look at the details of the code that we've programmed in. And like I said, this might be slightly different from the Blink example that you have, depending on what version of the Arduino development environment you're using, but the ideas are pretty much the same. So this particular program here has two simple functions. There's a setup function and a loop function. So let's look at the setup function first. So this setup function is simply an empty input function, that is, there's nothing in between these brackets. It's called setup, and this is a standard function. You always have to have this in any Arduino program. And any code that you have inside the setup function is only going to run once, just at the start of your program. And if you, for example, want to go back and run that setup function again, you would actually have to press the reset button physically on your Arduino or your Hapkit in order to get it to rerun. The other function here is called the loop function. And any code inside the loop function loops over and over again. And so the idea is that as quickly as the Arduino can, given whatever power it has, it's going to run through all of these commands, and then it's going to go back to the start, and it's going to start over again. It's just going to run these over and over as many times as it can. And if you've programmed before, this might be different from what you've expected, because a lot of programs, your goal is to make some kind of calculation and give an output, and then you're done. But in the fields of robotics and haptics and all kinds of mechatronic devices, you typically want a loop because you want to be running something over and over again, and the system will constantly be running and responding to things that happen in the world. This is a very simple loop, and we'll go into the details of what it does in a minute, but you can create much more complicated loops that can create interesting Hapkit effects or can create even sort of autonomous robotic behaviors. So let's look at the function that's being called in this setup function here. So there's this function called pin mode here, and the inputs to that function are the pin number of interest, as well as whether it's an input pin or an output pin. And basically, the setup function is just saying, I want to use pin 13 as an output. Because like I mentioned earlier, these digital input-output pins could be used as inputs or outputs, and so you have to specify what you want to use it for. And if your pin is an input, then you would be using it, for example, as a sensor or a switch. And in our case, we will be using it as an output for an LED in this case. So this pin 13 is connected to an LED on the board. That is actually not true. That is true for Arduino only. That's an Arduino feature. The Hapkit board doesn't have an LED inherently connected to pin 13, which is why earlier in this lecture you hooked up your own LED to it. So you are now connected to an LED, but that LED is not inherently on the board. So the other pins can be externally connected to whatever you want, and you just have to specify them as input and output before you use them. So let's look now at the code that's inside our loop function. It's very straightforward. There's really only two functions that are being used, and each one is being used twice. So the first one are these digital write functions. So what that is doing is it's taking a pin number and it's specifying whether that pin number should be high or low. All right? And so the LED is on in our case if it's high, and it's off if we make that pin low. And the reason why we run this digital write function twice, once high and once low, is because we want to make this LED blink. So we're going to turn it on high, we're going to wait a while, and then we're going to turn it on low. And when it turns on high, that gives it +5 volts, and when it goes on low, that goes to 0 volts. and that's why you're going to see this blinking effect. Now there's two other functions being used here, the same function being used twice, and that function is called delay. And that delay function specifies the delay, and this is important, in units of milliseconds. And what this does is make your Arduino, or in this case your Hapkit, wait for the specified number of milliseconds. Because if you didn't have that delay in there, the LED would actually blink so fast you wouldn't be able to even notice it. It would just look like it was on all the time, perhaps at a lower brightness than it would be normally. So it's important to have this delay so that you can turn it on, wait, turn it down, wait, and then you're going to loop over and over again, which is why you should see your LED blinking on and off, over and over again until you disconnect the power. So I want to mention a couple other useful and important things for programming the Arduino beyond this example. And throughout this class, we'll be giving lots of examples of programming the Arduino and Hapkit. But one of these is something we'll start with today, which is the serial monitor. The Arduino environment has a built-in serial monitor that you can use to communicate with your Hapkit board. Because once everything has been downloaded, that is, your whole program has been downloaded onto your Hapkit, if you had an external power source, you could disconnect the USB from your computer and the Hapkit could just be running on its own without any way for you to interact with it, for example, through keyboard hits or to look at data that's coming off of your sensors. So the serial monitor can be useful because if you leave your USB connection between your computer and your Hapkit, you can click on Tools and Serial Monitor in the Arduino programming environment, and it will allow you to view whatever is going on through that serial line. And the serial line is the USB line. So there are lots of different ways you can interact with the serial monitor, but here are two really useful things that you can do. We're going to look at how you print to the serial monitor and how you read from it. For printing, there are two examples here. The first example is just printing some text that says "Hello World." So you use the command serial.println and then in quotes whatever text you want to show up. And so if you've opened your serial monitor and this code runs, then you will just see "Hello World" appear in the serial monitor. One important thing to note is that if you put this command here, this print line into the loop, then every time it goes through the loop, it's going to be printing "Hello World." So on the serial monitor, you're just going to see "Hello World" over and over and over again. And the serial monitor, which looks just like a screen of text, will just start scrolling through as it gets too much information to fit onto one screen. So that's just printing a set of characters to the serial monitor. Another thing that you can do is actually print a variable, and this is super useful for debugging. So let's say that you have a variable called myVariable, and I've just defined it as an integer, and I've set it equal to 0, but in the real world you'd probably be sensing something that would be changing over time. Otherwise there'd be no point in looking at the value of that variable. So in this case, the command is the same. It's serial.println, but now instead of some characters there, you put in the words myVariable, whatever the name of your variable is. And then that number or that character, whatever that variable is, will get printed to the serial monitor. And there are other commands that you can find on the Arduino website about doing line returns, carriage returns, things like that. So that's printing to the serial monitor. Sometimes you also want to read from the serial monitor. It can be useful to change the state of your Hapkit, or if you're making a robot, to give it a command to turn left or stop by, say, hitting a key on the keyboard. And so if you want to read, this is for a keyboard press. If you go into the serial monitor, which has a little window on top, sometimes you'll see a cursor there, sometimes you won't. And you can type a key like A, and that will show up in that little window. And this code here will read that character, and it will store it in this variable called inByte. And you can be looking for different types of information. In this case, it's just looking for a character, which is a byte long. And so in some of the Hapkit code that we'll be doing, we'll be pressing different keys to switch between different types of virtual environments that you can program. So last, I want to mention a few programming syntax and hints for using the Arduino. These are especially important if you've never programmed before. So if you want to add comments to your code, which you really should, you should use a double slash. And if you add that double slash before any text that you want to have as a comment, then that text doesn't become part of your code, it's just a comment. And it is really important to comment well for a couple reasons. One is it'll really help you debug and understand what your program is doing. And then second, it will also help other people understand your code if you wind up sharing it, especially if you're sharing it because you're asking for them for help. So add comments as much as you can. The next point is that each statement must end with a semicolon. So a statement is something like assigning a variable to a value or calling a function. And you can see in the sample code that there's always a semicolon at the end of the statement. And that lets the compiler know that that's the end of that statement. So you have to declare, this could say must instead of just, you should declare variables before you use them. And so the point there is that you can't just go ahead and start using names for things that the Arduino or the Hapkit doesn't know about. You need to be able to specify that this variable, my variable, is an integer, for example. The other thing is that you don't really have to typically write a whole lot of functions of your own. There are many, many built-in Arduino functions that can perform inputs and outputs. And next, you should really use online resources. So this website here has a great and compact language reference that describes the structure, variables, and functions within an Arduino program. And to reiterate a point I made earlier, if you've never programmed before, the easiest way to learn is to really look at and modify example programs. And as you do this, don't try to modify too many things at once before testing your code. You should test often as you make small changes. That way you can understand what the implications are of every change you make, and then you'll be able to understand what you're coding much better. And there's many examples online, but also just even in the Arduino programming environment, you can click on File and then Examples in the drop-down menus, and you can get lots of different examples for things that you can do with the Arduino or the Hapkit board.